I'm Nick. I'm a senior developer advocate here at Viam, and today I'm showing you a project we worked on called Project Sunflower. And so we're taking some, for us, off-the-shelf parts that we have, and we wanted to prototype what looks like a sun tracking setup. And so we have a solar panel, we have a BeagleBone AI64 computer, we have a power sensor here, your standard LED, some GPIO servos down here set up in a pan tilt configuration, a USB webcam, and of course our panel again. And so in about a day, we had all this working together, and let me show you what we have. And so we have our Viam machine here called Sunflower, and we have our hardware set up. So all of these bits of hardware that we have are what we call modules and components. This is set up using everything straight from the registry or built into VM server / the RDK itself. And so we have our BeagleBone here, which gives us access to all those pins that we have here. We have access to our servo GPIO, so we have our pan servo, our tilt servo. We have the ability to control them just by having these built in. And so we can quickly move our servos back and forth. We can go to our tilt servo, and we can control that as well and see that position being updated in real time. We have our USB webcam, again, another built-in provided by VM server. And we can start seeing a live feed of everything going on here. Hello, hello, hello. And then we also have our power sensor. Our power sensor is another module from the registry. And we can start to see we have our voltage coming in, our current coming in, and even the total power being calculated. We can see it updating in real time as I flash an LED or a flashlight here. And we can see the LED lighting up. We can see our current being increased as I get closer here, and decrease as I go a little bit further away. And now we can see that happening. And that's getting automatically captured and synced to VM data as well, because I have it set up in my data manager to capture those data points at 10 times a second. And again, all this is now working. This was the easiest part of the setup. We just had to configure our modules here, wire up the hardware, and we're good to go. But we want to go a little further. We want to actually build something that could look like a solution, something automated. And so now that's where we have our services. Our services are made up of something like a base control. This control allows us to then compose different components, something like our two servos together, into something that I can control in one place. And so now using keyboard controls, again, something that is a built-in interface, I'm just building on the APIs that VM provides. And then from there, I wanted to actually do some more automation. So I have what I call the SunPose service. This is what a vision service is. A vision service takes in camera input and provides some visual intelligence. And so our visual intelligence in this case is going to be tracking the brightness of the image in different quadrants and tell us what direction is going to be the brightest so it can go moving towards our sun. And so I'm going to grab my flashlight again, and we can see our tracking. We can see those confidence predictions are really our brightness predictions. And we can see as I move the camera around, this is updating as quickly as possible using some computer vision in order to provide feedback to our machine. So now what do we do with that data? So now I am feeding that data into what I call the servo tracker. Allows us to, again, compose things together, iterate. I could swap out that vision service with something else in order to create a different automation based on something else. And so this has been passed to our servo tracker, and this is going to get enabled now. We can see it automatically start working. It's starting to track our light source and trying to find the center. And so it takes in that data, runs a control loop, and automatically finds the best position to get the most sunlight. And we see it stopping as soon as it finds that nice center point. And so now, because it's hardware agnostic, means I can swap out the underlying hardware without having to change any other part of my software. So if I want to upgrade it to smoother servos, if I want to upgrade it to something that's serial driven rather than GPIO, doesn't matter. As long as I can create a module for it, or there's one existing usually in the registry, I can now build out new applications and don't have to rewrite it from scratch every time I need to change out the computer, change out the sensor, change out whatever I have in place. And now that we have all of this working, is a VM machine, I can go create dashboards in VM data. I can create a mobile app or a web app for anyone to go and track what they're doing and see things happening in real time. And then I can also copy this into a fragment and create a fleet of these, whether it's 100, 1,000, a full sunflower field, if you will. And from there, we can see how quickly it takes from a prototype to production using Viam. Thanks for joining us.